Hello students and friends, welcome to my YouTube channel. Today I came entire beam UDL problem. So this will find the shear force and bending moment diagram. So given entire beam UDL and this is the overhang B to C overhang beam. Okay, overhang beam means no support in this point C. So support reactions A and B. So RA and RB is the support reaction and B and C is overhang beam. So no support, that's what is known as one side overhang beam. So first we'll find the support reactions. So support reactions, as we know, we are taking the two equilibrium equation. First sigma FV equal to 0. So here we are considering total upward force equal to total downward force. Simple way. So RA na of support reactions A plus RB support reactions B. This is called other side. Then downward force what is UDL only. So entire UDL is there. So we can take one time 2 into 6. 2 into 6. This is called load. Entire load we are taking. So now take the information about moment, bending moment. We will take the bending moment at point A. Bending moment we will take the second equilibrium equations. Moment at point A will be 0. So here also we will take clockwise is equal to total clockwise is equal to total anti-clockwise. This is the concept we are taking because we are not taking sign convention here. So total clockwise is equal to total anti-clockwise. Here also total upward is equal to downward force. Here clockwise is equal to total anti-clockwise. So what is point A? So directly UDL is coming. UDL load na clockwise coming. So what is the UDL? 2 into 6. 2 into 6. This is called load. 2 into 6. This is called load. Now half distance. What is 6 by 2 equal to RB. RB into 4. So this RB will get here. So RB will get here how much? RB will get 9 kilonewton. If you calculate, RB will get 9 kilonewton. Now RB will substitute in this equation. You can give equations number 1. So substitute RB in equation number 1 na 12 minus 9 3. So RA is equal to 3 kilonewton. So now we know the support reactions RA and RB. So RA is equal to 3 kilonewton. RB is equal to 9 kilonewton. So we'll write. So this is called 9 kilonewton. RA is equal to 3 kilonewtons I wrote. So okay, now we'll go the bending moment diagram calculation. So before this we'll draw the line, zero shear force line. So we'll extend this line here. So we'll draw first the zero shear force line. And after this we'll draw the calculations we'll do and then we'll do the diagram work. So, okay, so this is zero shear force line. This point A. So shear force diagram calculation. Shear force diagram calculations. So what is SA? Shear force we are taking symbol A. So SA will be how much? 3 kilonewton. So sign conventions you see. Without sign conventions you cannot draw. So this is section, downward force. This is right side, this is left side, upward force. So this we are taking positive. Now reverse, downward force taking negative. So this is the section, this is the section. Left side upward force is positive we are taking. So what is 3 kilonewton. 3 kilonewton. Now SB will take L. That means the support reactions are this point will not take. Will take only UDL, SBL. If we will take SBR, then this point load, this vertical force also will consider. So this is the RB. So what is this one? SBL just before this point. So what is there here? Shear force at this point is 3. 3 minus what is this downward force? UDL is coming downward force. 2 into 4. So 2 into 4, 8. So minus 5 kilonewton. Where? SBL minus 5 kilonewton. Then SBR, now we'll consider the RB also. So what is minus 5 plus 9? So minus down upward force, no? Upward force positive. So this is up to 5. So it will come plus 3 plus 4 kilonewton. SBL, how much coming this SBL calculation? So once we are taking SB, L will be minus 5 kilonewton, SBR will be minus 5 plus 4 kilonewton. So correct. Okay, then SC. What is SC? Shear force diagram for SC. So this is no load, but up to this point 4 and UDL is there downward. Downward will be negative. Because UDL will be downward. So how much? 2 into 2, 4. Minus 4. So it is coming 0. So shear force at point C will be 0. Okay, now we'll draw the diagram. Shear force at A, 3 kilonewton. 3 kilonewton. So draw this line, 3 kilonewton. Now UDL is there, no? So up to B, because it will cross the line. So draw this extended line. So SB, SP how much? SBL first, minus 5. So we'll draw this here. Inclined line it will go. It will be minus 5. So this is the 3 point A. Now this is point B. Minus 5. So 5 only we can write now. And this SBL means this upward force, the support reaction is not acting. SBR plus 4. So it will go here plus 4. It will go here SB plus 4. Right top here 4 kilonewton. So now you look here. Why you are taking SBL and SBR? How we are differentiating? SBL, once we are taking SBL before this point B, minus 5. And again same point, vertical force is there. So vertical force is there, SBR 4 kilonewton. So this way, here you are seeing UDL also acting and point load also acting. So now it looks, no, B point without reaction force RB, and this point considering the reaction force. Now again UDLs 0 is there, no? So draw the inclined line only. So why here? So here see, if point load will be there, shear force line will be horizontal line. If UDL will be there, if shear force line will be inclined line. So I draw the inclined line. Here also UDL, draw the inclined line. So this is C, this is B point, this positive, negative, positive. So this is the shear force diagram calculations for this. So draw this hatch line. So it will look shear force diagram. So shear force diagram is over. Now we'll go the bending moment calculation. Bending moment moment diagram calculation. So bending moment diagram calculation, bending moment at A will be 0 and bending moment at C will be 0, because no force left side, no force right side, so this will be 0. Now we'll take the bending moment at B. So at that point B, so here also sign conventions we should take. Before this we cannot. So this is clockwise, negative, right side, anti-clockwise, left side, negative. Then another sections here you take. This is clockwise, so this is anti-clockwise, positive, clockwise, left side will be positive. This is the negative. So this is the sign conventions we followed here. So now see, bending moment at A0, B. Now this is going clockwise. left side clockwise positive. So 3 into total distance, how much? 4. This is the one bending. Now at point B taking now UDL coming anti-clockwise, 2 into 4. So this will come minus 2 into 4. This is load, and half distance what is? 4 by 2. Because once we are considering the UDL, as you know, the UDL is a rectangular, also known as rectangular beam. So once we are finding the moment, we are taking load, because kilonewton per unit length. So load means 2 into 4. Then center of gravity point will be the half distance. So we are taking this. So if you will calculate this, bending moment at B will come. So how much we calculated? 2 into 4 into 2, minus 4 kilonewton meter. So minus 4 kilonewton meter. Now maximum bending moment na shear force will be 0. So this point we have to find out the bending moment. So before this point we have to calculate the distance for this point. So we'll consider one section. So this considering section XX, considering XX. So we need this distance. Suppose this distance we are assuming is small x. Suppose this distance we are assuming is small x, then this distance will be 4 minus x. This distance will be 4 minus x. So we have to calculate this. So we'll draw here this triangle. Like this is there. Like this is there. So this distance is x. This distance is 3. This is 4 minus x. This distance is 5. So here 5. So how we'll calculate? You see here, x by 3 is equal to 4 minus x by 5. If you'll calculate this, how much is coming? 5x equal to cross multiplication, 12 minus 3x. So 8x is equal to 12. So x equal to 12 by 8. X equal to 12 by 8. How much coming? 12 divided by 8 is coming 1.5. So x is coming 1.5 meter. So x equal to coming 1.5 meter. That means at point 1.5 bending moment will come maximum. So that maximum bending moment will calculate at that distance. So first we will draw the zero bending moment line, then we will draw this. Okay, so we will draw this here, maximum bending moment, zero bending moment line we will draw first. We draw. So already know point A and point C bending moment will be 0. Bending moment at point C, you give some point D, not there, no, A, B, C. So this point give D. So at point D bending moment will be maximum. So what is bending moment at D? Bending moment at D nothing but 1.5 meter. So how we'll calculate this? You take first mx, okay, or D, mx, okay, right, first mx. So we'll put the mx na 3 into x minus 2 into x, capital X, 2 into x, so into you give here 2 into x by 2. This is the bending moment at x. Now we'll put x equal to 1.5. What we got here now? So in this point bending moment will come maximum. 3 into 1.5 minus 2 into 1.5 into 1.5 by 2. So here we will get bending moment, maximum bending moment at 1.5. How much is there? 3 into 1.5 minus 2 into 1.5. So 2.25. So what is coming here? 2.25 kilonewton meter. So we got the maximum bending moment at 2.2 kilonewton meter. So we'll draw the diagrams now. So you see here, already I told For bending moment diagram, point load inclined line. For UDL will be the parabola. So now this is the parabola we have to draw. We draw the parabola at point D, 2.25. At point, this point is D. Okay. So we got this. Now, bending moment at B. How much? Point minus 4. So it will come minus 4. So it will be curve line only. It will be like curve line only. It will come minus 4. It's coming minus 4. This point is B. Then bending moment at C. So bending moment at C, 0. So this also curve parabola. This also will be nothing but parabola only, because this is the full UDL. So UDL means parabola. Here also parabola. You can draw little sharp. Parabola. This is curve line. Then this point we have to find the contraflexure point. This is called contraflexure point. What is the contraflexure point? If the bending moment crosses the sign positive to negative, in this point is known as contraflexure point. So that point, what is the distance, we'll find now. So this is the maximum bending moment. If they'll ask where the shear force will be 0, you find the distance in this way. Which this point is, what is the distance? I taken x we got 1.5. At 1.5 bending moment will be maximum. So bending moment, maximum bending moment over. Now we'll calculate the contraflexure point. So contraflexure point is nothing but where the bending moment diagram crosses the sign plus to minus. So this is the plus bending moment, this is the negative bending moment. Once it crosses the sign, that point is known as contraflexure point. So this point, what this distance we have to find. So how we'll find? If we'll take the bending moment calculation, this bending moment equations will be 0. So 3x minus 2 into x by 2 equal to 0. Then we'll get the this point, contraflexure point. So we can write here 3 equal to 2 into x by 2. So x equal to here we are getting 3 meter. So contraflexure point is 3 meter only. So contraflexure point they'll ask na, that point will be 3 meter point. So to get the contraflexure points, what we have to do? Equate the bending moment equal to 0. Equate the bending moment equations equal to 0 and find the distance, that is called contraflexure point. That point is that lies in between A and B. So this you give some name is E. So E is the contraflexure point from the 3 meter from the A. So this way we can find the contraflexure point also. So in this question, suppose they'll ask find the maximum bending moment, we calculate the maximum bending moment. If they'll ask show the contraflexure point, so now we'll take bending moment equations equal to 0 if we'll equate. So the distance will come x equal to 3 meter, that is 3 meter is known as contraflexure point. So okay, so this way we can calculate like these questions. Okay, so watch this video and subscribe the channels and share this video to your friends. Okay, students, thank you.